All right, I'm skipping ahead a couple sections, but we will be coming back to section 8.3 and 8.4. But we are going to be talking about a factoring method called difference of squares. This is going to be using perfect squares, which we'll talk about, make sure we know what those are. And difference means subtraction. So it's going to be subtraction and using perfect squares. So to start with, just so we can see where this is coming from, comparing it to things that we did first semester, I want to go ahead and multiply out some binomials. So remember, we would distribute this x to both terms, and then we would distribute the 4 to both terms, and we would be multiplying, okay? So to start, x times x, I'm getting x squared. X times negative 4, I'm getting negative 4x. 4 times x, I get positive 4x. And 4 times negative 4, I get negative 16. We're going to go ahead and combine like terms in the middle. This is the part that we sometimes get tripped up by because we have to make sure that we see the negative 4x and the positive 4x. And negative 4 plus 4 gives us 0, which means these two are going to cancel out. We don't need to write 0x because all of the x's just go away there, okay? That means I'm only left with x squared and minus 16. So that kind of gives us a clue into what we're going to do today, is because I see difference, I see that subtraction sign, and I see a perfect square 16 because I know 4 times 4 gets me 16. That's what it means to be a perfect square. So what we do today, this would be our first problem, and we would be trying to come up with our factors. So we would be working backwards from this, okay? Another one here, I want to distribute 5m times 5m. 5 times 5 is 25, m times m is m squared. 5m times negative 1, negative 5m. 1 times 5n, m positive 5m. And 1 times negative 1, negative 1. I'm going to go ahead and combine my like terms here. When I have negative 5 plus 5, I see that those are going to cancel out. That's what's going to happen in problems like this. That leaves me with 25m squared and minus 1. Both 25 and 1 are perfect squares, so we see that we could be working backwards with difference of squares. We'll see how that connects here in just a second. Okay, so just so we can see how this will work, when we are factoring difference of squares, we could still work on the factoring methods that we talked about a little bit last class, and we'll kind of see how that connects as well when we go back through section 8.3 and 8.4. But we have this shortcut that we could use when we see that we have difference of squares. Main thing here is that it has to be subtraction. The word difference means subtraction, so it has to have that in order to use this method. And both terms have to be perfect squares, okay? So what it means to be a perfect square is we get a nice whole number when we take the square root. So if I take the square root of 1, I get 1. If I take the square root of 4, I get 2. Okay, these are going to be good things to have down in your notes, so make sure you have these down. If I take the square root of 9, I get 3. Square root of 16, I get 4. Square root of 25, I get 5. Square root of 36, I get 6. So you can see we're getting these nice whole numbers every single time. So I'm working my way up. To get 7, I would need the square root of 49. To get 8, I would need the square root of 64. Square root of 81 gives me 9. Square root of 100 gives me 10. Square root of 121 gives me 11. And to get 12, I need the square root of 144. Okay, so this is going to be a good list to reference back to throughout all of our factoring work and factoring practice, because we need to start to recognize these perfect squares when we see them, okay? This difference of squares factoring method is going to be fairly simple for us if we are recognizing the perfect squares. Okay, so we have some perfect squares that we're going to use our difference of squares factoring method. So the first thing I look at is I have 1a squared and negative 4. Or I see 1a squared and a subtraction sign, which is difference. And I see a 4. Well, I know that 1 is a perfect square and 4 is a perfect square because they're both up here. So I know I can use difference of squares because I also have subtraction, which means difference. Okay? So what I want to do is I want to take the square root of each term. And we're not going to include that subtraction sign. We're just going to take the square root of positive 4. We know the square root of 4 is 2. And then the square root of a squared. Well, I know a times a gives me a squared. And 2 times 2 gives me 4. So if I am using 2 for the square root of 4, I'm going to use a for the square root of a squared. So I know it's variables, but we're working backwards from a squared. All right, anytime we're saying factor, we're going to set up our two sets of parentheses. I'm splitting apart the a squared here, splitting apart the 4 here, and we just need to remember that we will always have 1 plus and 1 minus. Okay? So maybe make a note in your notes. Always have plus and minus for our factors. Okay? On to my next one. I have 1n squared minus 64. 1 is a perfect square, okay, over here. 64 is a perfect square over here. So I know that I can use a difference of squares, and I'm going to take the square root of each term. The square root of n squared would just be n. Square root of 64 is 8. I set up my two factors. I put n and 8, n and 8, and we just need to remember to have 1 plus and 1 minus, and we have it factored. All right, I'm going to keep going. I see that 9 and 100, both of these are perfect squares. I have 9 and I have 100. So I have two perfect squares. I can do difference of squares. The square root of 9 is 3, and the square root of x squared is x. The square root of 100 is 10. So I'm going to set up my two factors. I have 3x, and I have 10. And we just need to remember 1 plus, 1 minus. Okay. I see on my next one 25 and 49. On my list of perfect squares, I have 25 and I have 49. The square root of 25 is 5. The square root of y squared is y. Then my square root of 49 is 7, and I can set up my two sets of parentheses. All right, so I have 5y, and I have 7. We need 1 plus and 1 minus. Okay, so Get that process down. Make some steps if you need. Okay, if it helps you, maybe make a note. Square root each term. Two parentheses. And we need 1 plus, 1 minus. Okay, if having those steps helps, do that. Okay, 3 more examples here. So I'm going to look for difference of squares. I see difference, but between 2 and 72, those were not numbers I saw on my list here. Okay, so what we want to check for is look for a GCF first. I'm going to go ahead and divide by my GCF. It looks like I can take out a 2, but I can't take out any variables. So I'm going to put that 2 in front. I'm left with n squared minus 36. Now I see a perfect square. I know 36 is a perfect square, and I know 1 is. So I can go ahead and take my square root of each term. I'm leaving that 2 alone in front for now. It's going to stay in front, and I'll set up my 2 sets of parentheses after. The square root of n squared is n, and the square root of 36 is 6. So I can set up my information here. And we just need 1 plus and 1 minus. The main thing here is make sure that you don't forget about this 2 that was in front. That GCF will have to be there for the answer to be correct. Okay, with 18 and 50, if it helps you list out your factors. I know my factors of 18, 1 and 18, 2 and 9, 3 and 6. Factors of 50, 1 and 50, 2 and 25, 3 doesn't work, 4 doesn't work, 5 and 10, 6, 7, 8, 9, 10. Okay, so we have all of our factors. So I see 1 in common, I see 2 in common, and that might be all. So looks like my GCF is just 2. So I can put 2 in front. I'm left with 9x squared minus 25. All right, same thing. I'm going to take the square root of each term inside my parentheses, leave that 2 out front, set up my 2 sets of parentheses. The square root of 9x squared, square root of 9 is 3, square root of x squared is x. Over here, the square root of 25 is 5. So I'm going to set each one of these within my parentheses. 1 plus, 1 minus. Again, make sure you have that GCF of 2 staying in front the whole time. All right, and last one here. This one's kind of our trickier one because if I look, I see 16 and I see 100, and these are both perfect squares when we look back at our list up above. But they have variables in common. So even though we have difference and 2 squares, 2 perfect squares, we still need to factor out a GCF. Okay. I won't list all my factors of 100, but I'll list mine of 16. And I know that 1 and 2 go into 100. 4 goes into 100. 8 will not divide evenly, and 16 will not divide evenly. So it looks like I'm left with a GCF of 4. And then I see an a cubed and an a term. Remember, we're going with our lowest exponent, which is 1, so I just divide by 4a. All right, that is going to leave me with 4a squared minus 25. I'm going to take the square root of each term just like we did before. Square root of 4a squared is 2a. Square root of 25 is 5. I keep that 4a in front, my two sets of parentheses after, and I put each of those terms within the parentheses. And we just need to remember 1 plus and 1 minus. So 4a times 2a plus 5 times 2a minus 5. All right, so the main thing here, check for a GCF first to simplify your problem. Always reference back to your list of perfect squares here. That's going to be very helpful for you. And then you need 1 plus and 1 minus in your sets of parentheses.